All right, let's jump straight into this explainer and unpack what's been a massive bottleneck in artificial intelligence. For the longest time, there's been this great compromise holding back unified AI models. But today, we're looking at a completely groundbreaking solution called Janus-Pro. We're going to see exactly how it fixes this fundamental flaw. No fluff, just straight into the architecture of how modern multimodal models actually see and create.
Here's our roadmap. Section 1, the unavoidable AI tension. 2, decoupling the encoders. 3, how data scaling works. 4, flow variance and beyond. And finally, 5, building with Janus-Pro. Let's get into it.
Section 1, the unavoidable AI tension, or really the fundamental flaws in unified models. So we have to start by looking at a major issue with previous unified models. Systems like Chameleon, Show-O, and Transfusion, they all share this common architectural choice, which is trying to force a single shared visual tokenizer to handle literally everything. It perfectly illustrates this inherent tension. Think about it. You have tools optimized for understanding semantics like SigLIP or Dino v2. These are fantastic at grouping high-level concepts. They know a cat is a cat. But then generation demands tools optimized for reconstruction, like a VQVA tokenizer, which captures incredibly fine pixel details but has, well, pretty weak semantic coherence. Trying to combine them? It's basically like using a spork. You end up making a really poor compromise between understanding deep semantic features and generating crisp, beautiful pixels.
The harsh reality here is that these two goals are simply not compatible in a single encoder. Forcing one visual tokenizer to handle both directions ultimately slaps a massive quality tax on either your generation or your perception. You just can't have frontier-level image understanding and frontier-level image generation if you're forcing both of them through the exact same bottleneck.
Section 2, decoupling the encoders, or separating the model's eyes and hands. DeepSeek's models, Janus and the newer Janus-Pro, propose a really radical shift in philosophy here. They basically say, stop trying to compromise. Instead, structurally separate the model's eyes and hands. The key to this decoupled encoding is that instead of one tokenizer, we use a separate one for each direction, a semantic encoder strictly for understanding, and a reconstruction encoder strictly for generation. By splitting these inputs up, we get dedicated, highly specialized tools that still manage to feed into the exact same shared transformer brain.
Here's how it actually routes. When you want the model to comprehend an image, you trigger it with an understand tag. The input image routes directly through SigLIP, taking full advantage of clip-style pre-training that's perfectly tuned for semantic similarity. From there, it passes through a 2-layer MLP adapter, right before hitting the shared transformer body. Boom, perfectly optimized for pure perception.
Conversely, if you swap that to a generate tag, the data routes through an entirely different path. Now, the data goes through a vector quantized or VQ tokenizer. It turns into token IDs, flows through that same shared transformer body, and outputs via a VQ decoder. This ensures the model's outputs compose back into pixels cleanly, completely free from any semantic compromises. But the true magic, that's all happening in the shared transformer body. This shared sequence processor consumes either the SigLIP vectors or the V2 tokens, and there are no modality-specific weights per block. What's really fascinating is that Janus-Pro initializes this body from a pre-trained large language model, DeepSeek MOE 7B specifically. It acts almost like a massive digestive system, easily absorbing the switching between the two encoders and applying deep, inherent LLM reasoning to the unified sequence. It's a massive, massive advantage over models built entirely from scratch. Section 3, how data scaling works, specifically looking at the jump from Janus to Janus-Pro.
Having the right architecture is great, but it's only half the battle. Scale is the other half. The original Janus model from October 2024 definitely proved the decoupling concept worked, but it was relatively small at 1.3 billion parameters. Janus-Pro? It dramatically cranks that up to 7 billion parameters. But the data mixture, that is the real secret sauce here. Stage 1 alignment data jumped from 72 million to 90 million image text pairs. Stage 2 unified training soared from 26 million to 72 million pairs. And crucially, they added a stage 3, packing in 200,000 specific image generation instruction samples. This massive scaling results in an absolutely astonishing 0.80 GenEval score. To put that into perspective for you, a 7 billion parameter open model using this exact decoupled architecture is actually beating OpenAI's DALL-E 3, which scores a 0.67 on that exact same benchmark. And get this, it does that while simultaneously matching Lava on the MMU perception benchmark,
We are talking about a single open model that is highly competitive on both sides of the unified spectrum. Section 4, Flow Variants and Beyond, looking at the new standard. You see, this decoupled architecture isn't just some one-off trick for Janus-Pro. It's highly modular and rapidly evolving into the overarching standard for multimodal AI. Take Janus Flow from November 2024, for example. This variant actually swaps out the discrete VQ generation path for a continuous rectified flow generation path. The shared body stays exactly the same, but the generation ceiling lifts even higher. It proves you can iterate on specific output mechanisms without breaking that core decoupled encoder's shared body framework. Looking slightly ahead, by the time intern VLU arrives in 2026, it completely subsumes this routing choice into its massive framework. It utilizes SigLIP for input and a combo of VQ and diffusion heads for output, all unified by the intern VL3 backbone. This is perfect proof that decoupled routing is no longer just a cool experiment. It is absolutely cementing itself as the undisputed default for building unified models at scale.
Section 5, Building with Janus-Pro and Choosing Your Stack.
Now that we understand the raw power of this architecture, let's talk about when you should actually implement it. As brilliant as decoupled encoders are, they do add some architectural complexity. 2 tokenizers mean 2 distinct input paths to maintain and 2 sets of fail modes to debug, right? So don't over-engineer. If your product only needs image understanding, just grab a Lava family model. If you only need generation, go with Stable Diffusion 3 or Flux. But if your product demands frontier-level unified capabilities, meaning doing both tasks seamlessly, Janus-Pro is now your reference open architecture.
In practice, implementing this in your own code is remarkably straightforward. Basically, you build a simple prompt router that seamlessly disambiguates tasks on the fly based on tags like understand or generate. This router then feeds the shared body exactly what it needs, either the semantic 256-dimensional vectors from your SigLIP encoder or the integer codes from your VQ encoder. Which brings us to an incredibly exciting frontier. If we can solve the compromise between perception and generation by decoupling 2 encoders, what is stopping us from adding a third? As you design your next multimodal application, consider how this exact decoupling philosophy might scale. Could a third pathway seamlessly handle image segmentation, or maybe Dino-style depth, routing straight into that exact same shared LLM brain? The end of the multimodal compromise isn't just about getting better images and text. It's the blueprint for teaching AI to interact with every single facet of the physical world.